Have you ever stopped to think about how massive apps, like Netflix or Spotify, can handle millions of us all at once without even a hiccup? Well, a huge piece of that puzzle is a technology called Kubernetes. And today, we're going to peel back the curtain and demystify its architecture. We're going to see what really makes these modern cloud applications tick.
All right, so here's our game plan for today. We're going to start with the 30,000-foot view, what a cluster even is. Then we'll dive right into the two key parts of any Kubernetes setup. You've got the control plane, which is basically the brain making all the big decisions, and then you have the worker nodes, which are the muscle doing all the heavy lifting. We'll see how they talk to each other, and really why this whole brain and muscle setup is such a game changer.
Okay, let's dive right in with the most fundamental piece of the puzzle, the cluster itself. When people throw around the term Kubernetes cluster, what should you actually be picturing in your head? Right, so first things first, get the idea of one single, super powerful computer out of your mind. That's not what this is. A Kubernetes cluster is much more like a well-coordinated team of computers, which we call nodes, all working together in perfect harmony. It's this whole distributed system that pulls all its resources together to run your apps, and that's what gives it that incredible resilience and scale. And the absolute key to understanding how a cluster works is this really clear division of labor. On one hand, you've got the control plane. That's the brain of the operation, the shot caller. And on the other, you have the worker nodes. They're the muscle, the ones that actually execute the commands and run your applications. Brains and brawn, plain and simple. All right, so let's zoom in on the brain of this whole operation, the control plane. This is the command center, right? It's where all the critical high-level decisions get made. And it's not just one thing, it's actually a team of really specialized components working together. And the first, and honestly the most important component we have to talk about, is the Kube APS server. Seriously, if you think of the entire cluster as a kingdom, this is the main gatekeeper. The API server is basically the central nervous system of the whole cluster. Every single command, every piece of communication, every action, it all has to go through the API server. There's no backdoor. Without it, your cluster is just a bunch of disconnected machines that can't talk to each other. And this thing wears a ton of hats. It's not just the front door. It's also the security guard handling authentication. It's the traffic cop directing everything. And it's the central coordinator for all the other components. It is a serious multitasker. Okay, so if the API server is the front door and the coordinator, then what's etcd? Well, etcd is the cluster's memory. It's the official book of record, the single source of truth for absolutely everything that's going on. So what etcd is this super reliable database that stores what we call the desired state of the cluster. Think of it like a blueprint. It's the master plan that Kubernetes is constantly looking at to make sure everything in the real world, the current state, matches up with how you want it to be. All right, next step in the control plane, let's meet the cluster's official matchmaker, the scheduler. Its entire job is to find the perfect home for your applications to run on, making sure they get all the resources they need to be happy and healthy. You can kind of think of the scheduler like a real estate agent, but for your applications. It's always on the lookout for new pods, and a pod is just the smallest unit that holds your app's containers that need a place to live. The scheduler then looks at all the available nodes or machines and finds the absolute best one for that pod based on its needs. And its decision process is basically a two-step deal. First, there's filtering. It looks at all the possible nodes and immediately throws out any that don't meet the pod's basic requirements, like not enough memory or CPU. Then, for the ones that are left, it moves on to scoring. It ranks them all and picks the one with the highest score. Simple as that. Okay, the last key player in our control plane is the enforcer, the one that makes things happen, the controller manager. Its mission is really simple. Make sure the current state of the cluster, what's actually happening, always matches the desired state that's stored in etcd. The best way to think about the controller manager is like a thermostat. It's constantly watching this state of the cluster, and if it drifts away from what you want, it makes adjustments to bring it back. So if a pod dies, for example, a controller notices and spins up a new one. This constant loop of watch and correct is the absolute heart of Kubernetes' famous self-healing ability. All right, so we've spent some quality time with the brain. Now let's head down to the factory floor and meet the muscle. It's time to see where the actual work gets done, the worker nodes. Now, on every single worker node, you're going to find a crucial piece of software called the kubelet. The best way to think of it is as the control plane's agent on the ground.
It's the on-site manager that carries out the orders from headquarters.
Yeah, it's pretty much the foreman for that specific node. It gets its instructions from the API server, and then its job is to make sure the containers it's been told to run are actually up, running, and healthy. It also reports the status back up to the control plane. Next up, on the worker node, we've got the kube proxy. This is the component that handles all the networking magic. It's the traffic director that makes sure all your different applications can talk to each other and to the outside world, no matter which node they're on.
Think of kube proxy as the local post office for that node. It maintains all the network rules, kind of like a list of addresses and forwarding rules to make sure that network traffic gets delivered to the right pods. It's the essential plumbing that makes communication possible.
And finally, the last piece of the puzzle on the worker node, but it's a big one. It's the engine itself, the container runtime. This is the actual software that does the work of running containers. Yep, the container runtime is the real workhorse. The kubelet tells it what to do, and the runtime does it. It pulls the container images, starts the containers, stops them, all the low-level stuff. Kubernetes is flexible here too. It can work with different runtimes you might have heard of, like Containerd or CRIO. Okay, we've met all the individual players in the control plane and on the worker nodes. Now let's put it all together. Let's see how this whole team works in concert to actually bring an application to life. But hold on, before we trace that journey, let's quickly clear up one of the most common points of confusion for beginners: the difference between a node and a pod. It's simple. A node is the machine, either physical or virtual. It's the house. A pod is the smallest unit you can deploy, and it runs on a node. It's like a room inside the house where your containers live. Nodes provide resources, pods consume them. So let's follow a pod's journey. It's actually a really elegant 4-step process. First, you, the user, tell the API server you want to create a new pod. Step 2, the API server validates your request and writes it into etcd, making it the new desired state. 3, the scheduler, who's always watching, sees this new unassigned pod. It does its filtering and scoring and picks the best node for the job, updating etcd with its decision. And finally, step 4, the kubelet on that chosen node sees it's been assigned a new task. It reads the pod's details and tells the container runtime to pull the image and start it up. And just like that, your app is running. Okay, so we've been deep in the weeds with all these components. So let's pull back up to that 30,000-foot view again. Why is it built this way? Why does this specific architecture actually matter so much? I think this quote really captures the shift we're seeing. It's not just about putting containers in boxes anymore. People are starting to see Kubernetes as something much bigger, a distributed operating system for this entire new era of computing. So this whole separation of the brain from the muscle, the control plane from the worker nodes, that's what gives Kubernetes its superpowers. It enables that incredible self-healing and massive scalability. But, and this is the big but, all of this power comes with a ton of complexity. And it leads to a really interesting question for the future. As this whole ecosystem keeps growing, at what point does that very complexity become the next huge challenge that we all have to solve?